according to section 210.11, Seat 1, B of the NEC 2002, where ground fault circuit interrupter protection is provided for personnel, the total number of cord and plug connected receptacle outlets on that branch circuit shall not exceed 12. This requirement aims to limit the potential leakage current on a single GFCI protected circuit and ensure effective protection. Now let's explore how the manufacturer's instructions weigh in on this matter, particularly referencing Square D's GFCI breakers. While the NEC 2002 provides a specific numerical limitation, manufacturer's installation instructions often offer a different perspective. Square D, for instance, emphasizes the ampacity of the device as the limiting factor. Square D's instructions state that the number of downstream receptacles that can be protected by a GFCI device is limited to the ampacity of the device. This means that a 20 amp GFCI device can protect a certain number of receptacles, keeping in mind the current draw of each receptacle. Typically, general-purpose receptacles are rated for 1.5 amps each. However, this is not a hard and fast rule, and the actual current draw can vary depending on the connected load. Considering the NEC 2002 and manufacturer guidelines, the engineer's statement is aligned with both the NEC 2002 and Square D's instructions. To summarize, based on the NEC 2002 and the manufacturer's instructions, a 20 amp GFCI can protect up to 12 downstream receptacles. This is because the NEC 2002 limits the number of receptacles on a GFCI protected branch circuit to 12, and the manufacturer's instructions emphasize the ampacity of the device as the limiting factor, which in this case, with a 20 amp GFCI, corresponds to the NEC 2002's limitation. Remember that while the NEC 2002 provides a specific numerical limit, it is important to consult the manufacturer's instructions for additional guidance. It is also important to consider the actual current draw of each receptacle. To expand on this topic, let's look at some practical implications. The limit of 12 receptacles on a 20 amp GFCI protected circuit is intended to prevent nuisance tripping. Nuisance tripping occurs when the GFCI device trips even though there is no ground fault. This can be caused by cumulative leakage current from multiple devices connected to the circuit. Each electronic device, even when functioning normally, can contribute a small amount of leakage current to ground. When the cumulative leakage current exceeds the GFCI's trip threshold, the device will trip, even if no individual device has a significant ground fault. By limiting the number of receptacles on a GFCI protected circuit, the likelihood of nuisance tripping is reduced. Furthermore, the limit of 12 receptacles promotes safety. In the event of a ground fault, the GFCI device will trip, interrupting the flow of electricity and preventing electrical shock. By limiting the number of receptacles, the GFCI device can more effectively protect individuals from electrical shock. Now let's examine how to properly install a GFCI device. Firstly, turn off the power to the circuit at the breaker. Secondly, remove the existing receptacle. Thirdly, identify the line and load wires. The line wires are the wires that provide power to the GFCI device. The load wires are the wires that provide power to the downstream receptacles. Fourthly, connect the line wires to the line terminals on the GFCI device. Fifthly, connect the load wires to the load terminals on the GFCI device. Sixthly, install the GFCI device in the electrical box. Seventhly, turn on the power to the circuit at the breaker. Eighthly, test the GFCI device by pressing the test button. The GFCI device should trip, indicating that it is functioning properly. In addition to the installation instructions, it is important to follow all applicable electrical codes. The NEC 2002 provides detailed requirements for GFCI protection. It is essential to consult the NEC 2002 to ensure that the installation is in compliance with all applicable codes. Let's discuss some common misconceptions about GFCI protection. One common misconception is that GFCI protection is only required in bathrooms and kitchens. While GFCI protection is required in these locations, it is also required in other locations, such as outdoors, in garages, and in unfinished basements. Another common misconception is that GFCI protection only protects against electrical shock. While GFCI protection does protect against electrical shock, it also protects against electrical fires. Ground faults can cause electrical fires if the current is allowed to flow through unintended paths. GFCI protection interrupts the flow of electricity in the event of a ground fault, preventing electrical fires. Another important consideration is the selection of the appropriate GFCI device. GFCI devices are available in several different types, including receptacle GFCI devices, breaker GFCI devices, and portable GFCI devices. Receptacle GFCI devices are installed in place of standard receptacles. Breaker GFCI devices are installed in the electrical panel. Portable GFCI devices can be plugged into a standard receptacle. The type of GFCI device that is appropriate depends on the specific application. For example, a receptacle GFCI device is appropriate for protecting a single receptacle. A breaker GFCI device is appropriate for protecting an entire circuit. A portable GFCI device is appropriate for protecting temporary electrical equipment. The ampacity of the GFCI device must also be considered. The ampacity of the GFCI device must be equal to or greater than the ampacity of the circuit. For example, a 20 amp GFCI device must be used on a 20 amp circuit. It is crucial to understand the difference between GFCI and arc fault circuit interrupter, or FSI, protection. GFCI protection protects against ground faults, while FSI protection protects against arc faults. Ground faults occur when electricity flows through an unintended path to ground. Arc faults occur when electricity jumps between two conductors. Both ground faults and arc faults can cause electrical fires. GFCI protection is required in locations where there is a high risk of ground faults, such as bathrooms, kitchens, and outdoors. FSI protection is required in locations where there is a high risk of arc faults, such as bedrooms and living rooms. It's also important to regularly test GFCI devices to ensure they are functioning properly. GFCI devices should be tested monthly by pressing the test button. If the GFCI device does not trip when the test button is pressed, it should be replaced. GFCI protection is an essential safety feature that can prevent electrical shock and electrical fires. By understanding the requirements for GFCI protection and following the installation instructions, you can ensure that your home is protected from electrical hazards. Furthermore, remember to consult with a qualified electrician if you have any questions about GFCI protection. A qualified electrician can assess your electrical system and provide recommendations for GFCI protection. They can also install GFCI devices and ensure that the installation is in compliance with all applicable electrical codes. In summary, the limit of 12 receptacles on a 20 amp GFCI protected circuit is a crucial safety measure. It prevents nuisance tripping, reduces the risk of electrical shock, and minimizes the potential for electrical fires. By following the NEC 2002, adhering to manufacturer instructions, and consulting with a qualified electrician, you can ensure that your electrical system is safe and compliant. To delve deeper into the practical application of these regulations, consider a scenario where you are wiring a workshop. The workshop has several receptacles for power tools, lighting, and other equipment. To ensure the safety of the workshop, you decide to install GFCI protection. Given the information discussed earlier, you know that you can install up to 12 receptacles on a single 20 amp GFCI protected circuit. However, you also need to consider the load on each receptacle. If you have several power tools that draw a significant amount of current, you may need to install multiple GFCI protected circuits to avoid overloading the circuit. For example, if you have a table saw that draws 15 amps, a drill press that draws 5 amps, and a grinder that draws 3 amps, you would need to install at least two 20 amp GFCI protected circuits. One circuit could power the table saw, and the other circuit could power the drill press and the grinder. This would ensure that the circuit is not overloaded and that the GFCI device can effectively protect against ground faults. In addition to the load on each receptacle, you also need to consider the location of the receptacles. Receptacles that are located in damp or wet locations, such as near a sink or outdoors, must be GFCI protected. This is because there is a higher risk of electrical shock in these locations. In conclusion, the limit of 12 receptacles on a 20 amp GFCI protected circuit is an important safety consideration. By following the NEC 2002, adhering to manufacturer instructions, considering the load on each receptacle, and considering the location of the receptacles, you can ensure that your electrical system is safe and compliant.